Jonapot Osvaldo Bayok. This is the University of Debrecen. And let me give you one reference about of the computer science. In this moment, I'm going to try one exercise by definition uh, by the indirect proof. So let's have a formulae. In this formulae, we have the formula A equivalence B, and the next formula is the next negation A implication B, and B implication A. We close it and we close the formulae. We know before that this is satisfiable. This is a satisfiable set. So in order to make the proper or the indirect proof, let's check the contradiction. So we can say that we indirect suppose that this set is unsatisfiable. This is unsatisfiable. Let's check that the opposite, it has a model. It has a model. That means the totally opposite. Let me explain you why. If we took this part, I'm sorry, if we took this part, we can say that A equivalence B is the interpretation is equals to 1. And the next one, I'm sorry for the focus, and this one, we can say that the interpretation of negation A implies B and B implies A by the interpretation is equals to 1. So let's make the contradiction between this formula and this formula. So we can start by dividing this. If this is 1, how can we get 0 to here? Well, the most important is this part, the negation. If we take out the negation of this formula, we will have the 0 value. So let's put the interpretation of A implies B and B implies A. If without of the negation, this is automatically convert to a 0 or false value. Let's check it out the next part. In the next part, we have the interpretation that A implies B. A implies B. The only chance that we can get 0 is that A is 1 and implication B could be 0. So this is the only chance that we can get 1, 0. And here, otherwise, the interpretation will be the same, because remember, to have 0, we must have 0 here and 0 here. So B implication A, that interpretation row is equals to 0. Let's final our exercise. The only chance that we can get 1, 0 here is that A is the interpretation is equals to 1 and B, the interpretation row is equals to 0, so we can get 0. In the next part of the definition, the only chance that we have 0 here is that B is equal rho to 1, and implication A, the implication A is equals to 0. So you can say, well, and what this mean? What these both interpretations can have a meaning for me? Okay, remember that here we have A equivalence, B is equal to 0. But if you check, if you construct something with this interpretation, the indirect, you will have a contradiction, because if you put the formula A equivalence B using this A and this B, you will have the interpretation here that this is equals to 0, because 1 and 0 is not equal, it's not equivalence, because they are two different rows. As well, in this part, we have the B, which is meant 1, and A. If we construct one formula, the result, it will be 0. So here and here, we find a complete contradiction. So that means this formula is not satisfiable. That means, in other words, this the opposite can be satisfiable. So thank you for watching this video, and I'll give you more information about the logic and computer science.